Welcome to Techtorial Shorts, Curious Minds. Today, we embark on an exciting adventure into the world of Python programming, a versatile language that is crucial for DevOps engineers to build reliable and efficient systems. In today's video, we'll unravel the mysteries of Python variables, more arithmetic operators, and their importance in Python. So join me as we explore the foundations of Python programming, enriching our understanding of the technological landscape that surrounds us. Now, let's start with the variables. What are variables in Python? Variables are name allocations, a location in a memory that is attached with the name that will hold certain values for us. So we can use these values later on in our code. These values could range from being a number to text to list and so much more that we'll cover later on. However, for these specific purposes, we'll take a look at the numerical data types, numerical variables. So first of all, what are numerical data types? There are three numerical data types in Python: float, integer, and complex type. So what are these types and what do they mean? Integer data type means that it's a whole number, could be positive, negative, but it's a whole number without a decimal point, such as -1, 0, 2, 3, 10, 1,000, 2,000, 336, etc. These are all integer numbers because they don't have a decimal point. Float type means that a number with a decimal point could be negative, positive, or 0. Could be 1.2, 3.14, 2.7, 31.32, 43.60, etc. All are float type because they have a decimal point. And the third type, we have the complex type. What is complex type? Complex type consists of two parts: a real part and an imaginary part. An imaginary part represented by letter J. Complex time is not commonly used in DevOps field. Therefore, I'm not going to dive into more details. However, just know that there is a complex type consists of real and imaginary part, and that all should cover us. Now let me share my screen to show you guys how do we create an integer variable, float variable, and complex variable. So when we look at our presentation here, we can see how definition of the numerical data types. Numerical data types is to store numbers, and then they are immutable, which means that if we don't reassign them, so if we don't specifically reassign them any value, they will not change their value. Okay, but this concept will be covered more in the later topics. But for now, you can just keep in mind they are immutable, and that's it. How do we create an integer? To create an integer, we just have to give a name such as a and use the equal sign and 5. In this case, this letter A or this name A in Python code is attached with the value 5. So whenever you try to do something with the A in this Python code, it will act as number 5, and this will be integer because this is a number without a decimal point. Now let's see how we create a float variable. To create a float variable, we need a number with a decimal point. Could be any number, negative or a positive. As long as it has a decimal point, it's a float number. Now, again, to be able to create a float variable, we have to give a name. In this case, we use the name B, and then use equal sign and give a number with the decimal point. And another example that I want you to pay attention is, if I say B equals 10.0, again, this is a float number. Even this is just a 10, since it has a decimal point, even with the 0, in Python programming, this will be understood as float type, not integer. Next, the complex numbers. To be able to create a complex number, we have to use the letter J, which represents the imaginary part. And such as C, variable name. Variable name, we'll talk later more what we can use and what we cannot. However, let's say we name this variable with the name C. And C equals 43 plus 6J. This is a complex number. The 6J, so 6 is the imaginary part, 43 is the real part, and that's all about it. Just know that this data type exists and used in Python. So what you should be careful when you are naming variables, right? First, let's look at the naming rules. Names must begin with a letter such as from A to Z, uppercase or lowercase, or an underscore. We cannot start your naming with the number, hyphen, etc. Your name must begin with letter or an underscore. After the first character, names can contain letters, numbers, or underscore. Okay, so we cannot use the numbers, only for the first character of the names, such as I can't do, let me show that I can't do 1 num equals 3, because this will create an issue, because I cannot start naming with the number. And what is the next rule? The next rule that we have is names are case sensitive. Okay, so which means this variable name and this variable name is not the same. As you can see, since the v's are in a different case, this v is in upper, this v is in lower case, this doesn't mean the same variable. Okay, Python names are case sensitive. Certain names are reserved and cannot be used as variable names. For example, you cannot use if, else, for, while, or def as a variable name, because these are reserved variable names. Okay, these are reserved keywords in Python that has a function. Therefore, these cannot be used as a variable name. And lastly, this is the suggestion. Names should be descriptive, meaningful, but not too long as well. And then these are the naming rules that we have in Python. Okay. And next, let's look at the more arithmetical operators. We have integer division, or so-called floor division operator, remainder of a division, and exponentiation. Such as, let's take a look at some examples. Normally in Python, I can create a two integer variable, a equals 20, and then b equals, let's say, 6. And in this case, if I say print A divided B, it'll print me 3.33333, which means that I'm getting all the decimal points. However, what if this question was in this case, right? What if this question was the 20 new DevOps engineer joined our company, and our company has 6 different teams. Okay, send this DevOps engineer equally for all the teams in the company. In this case, to be able to find how many DevOps engineers should go to a team, I have to say 20 DevOps engineer I have, and then they should go to 6 different teams. In this case, I can just say, okay, 20 divided by 6. So let's say name DevOps engineers, and then B is the teams, right? And then to be able to find how many DevOps engineers each team will get, I just have to say DevOps engineers divided by teams will give me. However, when I do that, I get 3.3, but I cannot send 3.3 DevOps engineer to one team, right? We cannot divide one engineer into 3. Therefore, we should not be getting these points, right, for this case. So in this kind of situation, to be able to avoid, so in order to avoid getting decimal points, floor division should be used. Okay, and then we can just say print DevOps engineers floor division with the teams, and then each team will get 3 DevOps engineer. However, I sent into 6 teams, and each team got 3 DevOps engineers, right? So I sent 3 DevOps engineer to each team, and there is total 6 teams. Now, in this case, 2 DevOps engineer are not sent to any teams. They are the remainder, right? And then to be able to find what is remaining after a division operator, we can use percent sign or so-called modulus operator. Let's use it. So I can say to find DevOps engineers that don't have a team, I can do print DevOps engineer remainder teams, and then it will give me 2, which are the remaining after this division operator, right? So you can find, in this case, by using a remainder operator, how many DevOps engineers are not sent, right? And lastly, we have the exponentiation. And exponentiation is a little bit different. Exponentiation is the power of the number, okay, such as 2 to the power of 3 is 8, because 2 to the power of 3 means multiply the 2 3 times, right? Or 4 to the power of 2 is multiply the 4 2 times. So 4 multiplied by 4, and then which will give us the 16. So to be able to do this with the Python, we use exponentiation, which is represented by the exponentiation symbol is represented by this one, and it's mostly used for some growth calculations or etc. However, so if you ever need to use it, you can use exponentiation, and we can give one example. 4 to the power of 3 should be 4 multiplied by 4 multiplied by 4, which will give us the 64 at the end. And that's all. Conclude our video. These should give you a solid understanding of all these topics. I hope you enjoyed it, and I am looking forward to see you guys in the next video. Have a great day.